Let's continue. We are on the section 2.3, page 17. We are going to talk about expressions and formulas and using order of operations. Okay, look at your page 17 on the top. Calculate powers and square root of a number in expression. Usually we say math language, we use expressions and formulas, right? If we try to find the answer, and for the first one, let's see. If we want to find the probability that if we toss a 6-sided die 5 times, that the first 2 rows will each be a 1 or 2, and the last 3 die rows will be even, then the probability is such a way. What is this probability rounded to 3 decimal places? Okay, when we threw how many dice? Let's see, we toss a 6, just toss 1 die. Okay, so if you have 1 die, how many, say 0.102 for the first time, then last 3 times will be even. Then probability will look like this. You don't know why, but you will learn this later. Okay, but for the moment, we just give you the answer, say probability will be this one. The question is, what is the probability rounded to 3 decimal places? All you need to do is just round this one to 3 decimal places. So if you enter to the calculator, what do? You say 1/3, right? 1 divided by 3. Then you better put a parenthesis, then take a power of 2. If you enter like this, 3 and 2, you will follow the order of operation. That's what we are talking about, right? Then you will do 3 to the square power. Second power will be 9. So this one will be 1/9. It's a little bit different. Okay, so we don't do that way. Okay, then for this one, 1/2, you will do 1.5, 1 divided by 2, right? Then you take a third power, right? Then you multiply them together. You need to enter this. Like a 1/2, this one just happened. If you don't use a parenthesis, you might still get the same answer. Okay, but don't do that. You just follow the order of operations. All right, so it will give you this one. Definitely you need to practice yourself with calculators. Okay, then we wanted to do how many decimal places? 3. 1, 2, 3. You don't want the rest of them, then you round up. So the answer should be 1/4. Right? Okay. Second one, the z-score is for the value of 28 for a sampling distribution with sample size 60 coming from a population with mean 28.3 and standard deviation 5 is defined by z equals something. You will still have problem to connect with each names with the value. Okay, so but for this one, then we say z-score is this. It's given. But at least you start to get familiar with something, the name called z-score, right? But you don't know exactly how you are going to use it, how to apply. But At least you say z-score is this. For the value of 28 is your sample distribution with the size 60 is here. And from a population with the mean is this one. Okay, 28.3. And we wanted to calculate the result. Then we know the division is a group symbol, right? So when you enter to the calculator, you better put this one, then divide by next one. It's a two different group, right? So this one will be 28 minus 28.3, right? Then this denominator is another group. Should be 5 divided by this. But you know this is another group here, right? So you should have 5 divided by, okay, another group. You should do that 60, and to the square root we use what? Half power. It should be this way. But for this one, just happen to be, if you write it this way, 5, just one parenthesis, 60 divided by this one, you will be okay. You short one parenthesis. However, but we say, right, like pandas, parenthesis, exponent, right, exponent, then you do exponent first, then you do division. You end up the same from the order of operation. Got idea? Okay? So if you short one parenthesis during the input to your calculator, it will give you an error. Right? So mainly is how to use your calculator to input the data and to make sure the answer is what you want by the order of operation. Mainly is we need to do that. Okay, then we are going to do is the second one, use order of operation again in the formula. Okay, see how we are going to plug in and with the order of operations. Look at the next example. Here says, the sample standard deviation asks us to add up the squared deviations. Take the square root and divide it by 1 less than the sample size. For example, suppose there are 3 data values, 3 and 5 and 10. The mean of this value is 6. Then the standard deviation is this way. So we are talking about sample standard deviation. So this is your sample standard deviation, right? And calculate it this way. Okay, you need to do value. It's a, you have what? The mean. Mean is average. It's 6. Okay. Then we are going to we have 3 numbers. That's how you would do 3 numbers. It's 3, 5, and 10. Okay. Then by then you have to remember this formula. But now we will give to you. Okay. You will use the individual number. Okay. Then minus your mean, okay, average. Then you take a square here, okay, that's the formula for S, okay, sample standard deviation. Then you divide by how many numbers we are dealing with, 3 numbers, okay? Then minus 1. That's the formula. It will be given to you, okay? But the idea for now is if we give you this, you know how to plug in and what kind of result would be with all the numbers. Then you need to follow the order of operations. Okay, so you just do it one by one, right? So the line is a group. You do it separately. The bottom 3 minus 1 is 2. That's fine. The top, you have to do the parentheses first. So 3 minus 6 is what? Negative 3, right? And 5 minus 6 is what? Negative 1. The calculator will not help you at this point. You have to do it by hand and your head, right? So 10 minus 4 is what? 10 minus 6 is 4. Take a square. So if you want to simplify this, you have to do it separately by the group. And after that, right, this is the group. Then you do it individually. Take a power first before you can add them, right? You will have 9 plus 1 plus 16 there. Then you add them together. 10, is that right? 26, right? 26 over 2. Then what do? You divide them, right? So that would be 13. Then you will use calculator. You say, okay, square root is 0.5 power. Then we will have 3.60555. It says how many decimals do we need? Rounded to the nearest hundredth, right? Hundredth is this. We don't want this. Round up. So your answer should be this one. Okay? Look at the next example on your page 18. Let's see, what do we need to do? When calculating the probability that a value would be less than 4.6, if the value is taken randomly from a uniform distribution between 3 and 5, we have to calculate something, right? To calculate this. But why is this way according to the condition and to calculate a probability, okay? So you will not know why it's this way, all right? Because you don't know what does uniform distribution really mean and what does randomly mean, okay? But we give you this one. What was the question? We have to calculate this guy, and this guy is the probability we are calculating, okay, for something less than 4.6, and take randomly from, okay, uniform distribution, the number 3 to 7. So you have a number 3 to 7, maybe, 3, 3.1, 3.2, 3.11, 3.5, things like that, all the way to the 7. The probability to pick the number would be less than 4.6 would be this way. Okay, it's given to you, but we want you to find the answer with one number. Okay, then if you enter to the calculator, you can do it individually. 4.6 minus 3 is 1.6, then times 1 over 4, right? Or you can enter just into the calculator. If you do that, you have to do by group, right? So that's your group. Then you have to times for this one, right? So it will be 1 divided by not the 7 minus 4, 7 minus 3, because division is a group. So if you do that, you need to put another parenthesis there. to get the right answer. That's what we are talking about. If we give you a formula like this, then we have to use what? The order of operation. Okay, you have to do 7 minus 3, so it's 1/4. If you do like this, 1 divided 7 minus 3, what does calculator will do? They will do 1/7 minus 3. You end up is a negative 2 6/7, right? This way. But originally 1 divided by 7 minus 3 is what? 1/4. It's a different answer. You cannot do it this way. You need to use what? The order of operations concept when you enter to a calculator. Okay, that's important. Right? Look at the next one. For a quantitative study, that means you study bunch numbers, okay? The sample size n needed in order to produce a confidence interval with a margin of error no more than plus minus e is this guy, n equals something. Where z is a value that is determined from the confidence interval and sigma is the population standard deviation. You want to conduct a survey to estimate the population mean amount of the years it takes psychologists to get through college. And you require a margin of error of no more than plus minus 0.1 years. Suppose that you know that the population standard deviation is 1.3 years. If you want a 95% confidence interval that comes with a z equals 1.96, at least how many psychologists must you survey rounded to your answer up? Okay? What are we talking about? Right? Let's write it from the top. So we have so many things we don't understand. So one thing is called sample size. Right? You start to get familiar with this now because we saw it earlier. So for sample size n needed in order to produce a confidence interval. So you don't know what is confidence interval mean, right? And with a margin of error. So we start to introduce a lot of names, no more than plus minus e, okay? So we have something sample size, confidence interval, margin of error, plus minus e. Then also we talk about something is z. So you have a formula. It's n equals z sigma over e take a square. Okay, we'll give you that. But you know n is the sample size. Then there is no confidence interval yet, right? Margin of error is plus minus e. So e means here is a margin of error. Okay? Well, z is the value of determined from confidence interval. So here is something related to here. Z is decided, okay, from confidence interval. It will be given to you, okay? And we need a z, we need a n, z, sigma, e. We mentioned the z, we mentioned the n, we mentioned the e. But how about sigma? Okay, it says sigma is what? The population standard deviation. So sigma is what? Population standard deviation. Okay, and what else? So to calculate n, we need a z, we need a sigma, we need E, right? E is here. E is what? The margin of error. Okay, and let's see what else it tells us. You wanted to conduct a survey to estimate the population mean amount of years. Okay, what is population mean? Where is it? Okay. Okay. It takes a psychologist to get through college, and you require a margin of error of no more than plus and minus 0.1. So it tells you require a margin of error of no more than plus minus 0.01. Whatever, so this one should be what? 0.1, right? Plus minus E, plus minus 0.1. So that's your margin of error. Suppose you know that the population standard deviation is 1.3. What is population standard? Oh, right here. Population standard deviation is what? It says 1.3. So that's 1.3, right? If you want to have a 95% confidence interval, so this one is 95%, okay? That comes with Z equals 1.96. So Z is 1.96. Okay? You don't know why Z is 1.96. It's given to you, okay, when the condition is, you know, you have 95% confidence on your result. Okay, that's what it is. And how many psychologists must be surveyed? How many means what? What's the size of the survey is N. Okay, so let's read the question again. For our study, the sample size N, okay, needed to be this way. Then with all the given Z sigma E to be able to calculate N. That's what you need to do. That's what it's saying. Okay, so how do we do that? So you use the formula N equals Z sigma E, then square. Then you plug in, right? So what is Z? So you need to identify the formula we need to use. Then identify each variable, what kind of numbers we need to plug in by connecting what they are saying in a question. Somewhere along the line, it will tell you, say, population standard deviation, sigma is this, and tell you the number, then also tell you the E, margin of error, right? So Z is 1.96, it tells you, then times sigma is 1.3, right? Margin of error, Z is 0.1, then you take a square, right? When you enter to the calculator, then you need to do parentheses first. So you do the parentheses, right? Then you do what? 1.96 times 1.3, right? Then you divide it by 0.1. Okay, you can do a group here as well. That's fine. If you don't, that's fine too. Because you do it left and right, you will cover the group already. Either way will be fine. Okay, so you don't need this. You just multiply and divide, right? And take a square, you use this one, right? Power, head to the square. Then what do we have? 649.2304 rounded to the, because this is a sample size you are going to use to survey people. So we round it to the whole number. If it's decimal, you round it to a whole. Round it to a whole number, we need to do what? 650 people, because you cannot, just drop 0.23 person, because you need to more than that, 649. That means you need to survey 650 people. Okay, so your conclusion should be what? So you draw a conclusion, say we need to survey, that was the question, how many people you need to survey. So you need to survey how many? 650 psychologists. Right? That's what we need to do. How to connect the words with the questions. So you get used to it. Okay? You have so many words. Okay. See, gradually you get familiar with. So let's look at the next example. Number 4 on your page 19. Okay, z-score. At least when you see z-score, you know it's something you have done before, right? So here says the z-score for a given sample mean x bar for a sample distribution with popular mean mu, popular standard deviation sigma, sample size n is given by this. So you will be given a formula. In stats class, you need to remember the formula when you understand its meaning later. Okay, but now it's given to you. We are doing the z-score. It will be calculated by this way. X bar minus mu over sigma over n square root of n. Right? So if we want to calculate z, we need to have what? X bar, we need to have a mu, we need to have a sigma, we need to have n, right? To be able to. Then you follow through, then see what do they mean. So let's start over again. So the z-score for a given sample mean X bar. So you will know later, X bar is always used for sample mean. So you have two things. One is the samples, one is populations. Then later on you will understand what's the difference between the sample and the population. Okay, two things you will see. One is called sample, one is called population. You will see the difference. Then another one is what? Standard deviation. Standard deviation means deviate from the standard somewhere. Okay, you will learn those meaning. So you start to get familiar with, we have something talk about something mean, it's average. So something called sample mean, population mean, sample standard deviation, population standard deviation, okay? But the formula is just math symbols. So X bar used for sample mean, and mu is used for what? Population mean, average, right? So it's talking about mean. Then you have two kinds. One is a sample, one is a population. Same thing for standard deviation. One is for sample, one is for population. Okay, you will get used to it later. So the sigma, it says, is what? Population, standard deviation. Then n is what? Sample size. It says, if we have sample mean, population standard deviation, sample size, if we have all those numbers, then we can just plug in, find the z-score. That's what it's saying for the first two lines. Okay, then let's see something below. it says an environmental scientist. Okay, so we are going to use this on environmental science. Collected the data on the amount of glacier retreat. So when they measure glacier retreat, they will get all this data. Then they want to find the z-score for using for something else. Okay, so she measured 45 glacier. So there is a 45 glacier. What do you think? Where to put a 45? Okay, and the population mean retreat is 22 meters, and the population standard deviation is 16 meters. The sample mean for her data was 27 meters, and the sample standard deviation for her data was 18 meters. What was the z-score? We want to find the z, right? Then we need these 4 numbers. Then it says bunch of things. Then you have to match all the things they say into here so you can plug in, right? Okay, let's do it again. An environmental scientist collected data on the amount of glacier retreat. She measured the 45 glaciers. So where is 45 fall into? She did a survey, total 45 cases, 45 glaciers. So that's her sample size, 45. Okay? Then it says the population mean retreat is 22 meters. Population mean. So that's what? Population mean is what? 22 meters. And population standard deviation. Population standard deviation is 16. Okay? Then the sample mean for her data was 27 meters. Sample mean. Here is sample mean. Okay, so you have 2 types, sample and population. So you have sample standard deviation, sample population standard deviation. So you also have what? Sample mean and population mean. So you have those. Okay, then you have sample means you actually collect the data from the samples you use from the survey. Population means in general for that category. Okay, for the whole populations. That's what it means actually. Okay, so at least we understand how to apply to find the result, the question, right? Because you have to just plug in the numbers with a bunch of words, then plug into the formula. All right, so let's see. Sample standard deviation. We also have what? Sample standard deviation is 18 meters, right? It says we have how many numbers? 45, 22, 16, 27, 4 numbers plus 18. But what it was the z-score? Z-score, we don't use sample standard deviation because we use all the symbols here, right? So you plug in z equals x bar minus mu sigma square root of n. So that would be plugging. X bar is 27, mu is 22, then sigma is 16, n is what? 20, n is 45. Right? If you want to enter this to the calculator in one shot, you need to follow the order of operations. Right? So that's the group divide. Okay, so divide. Here is the group numerator and the denominator. Right? Numerator is 27 minus 22. You are fine. How about the denominator? Denominator is 16 divided by 45. square root of 45, you use 0.5 power. It's better to put a parenthesis. But if you don't here, you still get the same answer because you will do the power first by order of operations. But we just use the parenthesis this way. Or you can do it individually. 27 minus 22 is 5. Then you calculate this value. Then you divide. Okay? So you should have the answer is what? 2.09631. So you round how many decimals? It says, did they say anything? Okay, I'm just checking the question. Okay. Did they say anything about how many decimal places? It didn't. Okay, if it didn't, let's just give a 4. Good enough. Okay, 4 numbers. We don't need this. 2.0963. So if you answer this, that's good enough. If it didn't tell you how many decimals, okay, that's good. Get idea? Probably not. But anyway, you can practice, okay? Do your homework. Each one has different similar questions for you. And for your exams, first exam, right, after this chapter, then we will have this kind of questions, but may not be as complicated as what we say here with a bunch of words, but you can kind of get familiar. At least now you start to get familiar. Z means z-score, right? N means sample size. At least we got that. And we use sigma a lot. See? Different questions. Sigma here, we always use for what? Population standard deviation. Okay? Then X bar, when you have bar there, then we always use for the average, mean. Gradually you will connect all those symbols with the terminologies. You know, we always use certain way, then you can kind of connect. You should be okay. Okay? So you start to have what? Population mean is always this, mu. Then sample mean is this way. Okay? So that will cover your section 2.3.